Welcome to this video on reactance. Reactance is a new term that we haven't covered before, and it's given by the letter X in most formulae, and it's measured in ohms. Now, we've covered the topic of resistance, which is also measured in ohms, but reactance is not the same as resistance. We come across reactance in AC circuits. So you'll notice here I have an AC supply in the circuit, and it's connected to an inductor, not a resistor. Reactance occurs in two components. One of them is inductors, and the other one is capacitors. So we're going to look at a few examples in this video, but first of all we're going to look at an example involving an inductor, and then we're going to look at another example involving a capacitor. So first of all, since we're talking about inductors, I'm going to write my formula here for X reactance with a little subscript L, XL, and that tells me that I'm dealing with an inductor in this particular circuit. And the formula to calculate reactance is 2 pi FL. So in this case, 2 pi we're familiar with, but the F represents frequency, which is given by the supply here, 50 Hertz, and L is the inductance, which in this case is 100 millihenries. So let's go ahead and calculate the reactance of this particular inductor in this circuit. So we have 2 pi multiplied by 50 multiplied by 100 millihenries, 100 times 10 to the minus 3, and that gives me an answer of 31.42 ohms. Now it's important to realise that although my reactance is measured in ohms, reactance is not the same thing as resistance. They both have the same effect of limiting current, but they're not quite the same thing. In our next video on impedance, we're going to look at the two different types, resistance and reactance, and how they can be combined together. But now we've calculated the reactance in this circuit, let's go ahead and calculate the current that's going to flow in this circuit. So I'll mark that on here as the current I. And we know the formula for current, Ohm's law, I equals V over R. But in this case, we don't have R, we don't have a resistance, we have a reactance. So I'm going to say that my formula is now I equals V over X. Or XL, I could say. And we know that V is 10, and we now know that XL is 31.42. And that gives me a current in this case of 318.26 milliamps, or 0.318 amps. Let's have a look at another example now, but in this case involving a capacitor. So I have a capacitor in this circuit now, a 270 microfarad capacitor, and it has the same supply, 10 volts at a frequency of 50 Hertz. First of all, we're going to calculate the reactance of this capacitor, and reactance, we said, has the letter X, but in this case I'm going to mark it with a subscript C, XC, because we're dealing with the reactance of a capacitor. And the formula to calculate the reactance of a capacitor is also slightly different. It's 1 over 2 pi FC. So let's go ahead and calculate this value, because this is going to be 1 over 2 pi times 50, the frequency, times our capacitance, which in this case is 270 microfarads. So that's going to be 270 times 10 to the minus 6. And calculating that gives me a reactance of 11.79 ohms. Now that we've calculated that again, let's work out the current in this circuit, I. And again, we can use Ohm's law, slightly modified for the fact that we're dealing with reactance, so that's I equals V over X. And we can say that that's 10 over our reactance, which was 11.79, and I get an answer of 0.848 amps, or 848.18 milliamps. Let's look at one more example involving a capacitor, but this time a little different, because in this case we've been told the current. We're saying here that we've got a supply of 10 volts at a frequency of 50 hertz again, and we're allowing a current of 2 amps to flow in this circuit here. And the question is, what capacitor is required in order to allow that current of 2 amps to flow in this circuit? So let's return to the same formula that we saw previously, which was I equals V over X. Well, in this case, we know I, it's X that is the unknown. So we're going to rearrange that formula to the form X, or in this case XC, equals V over I. And if we fill in those values, we know that V is 10 volts, and we know that the current in this case is 2 amps, and that's going to give me a reactance of 5 ohms. The question still isn't answered though, because we're not asked for the reactance, we want to know the capacitance. What value capacitor is needed here? And again, we need to return to our formula for XC, because we know that XC has a formula of 1 over 2 pi FC. Well, we can rearrange this formula for C, and it'll look like this. C equals 1 over 2 pi FXC. So if we fill out our values here, we know that that's the same as saying 1 over 2 pi times 50, the frequency, multiplied by our reactance, which we said was 5 ohms. Calculating that gives me a very small number of 636.62 times 10 to the minus 6. And it's a capacitance, so it's measured in farads. Now we know times 10 to the minus 6 gives us one of our standard prefixes, micro. And so I could just as easily say 636.62 microfarads for our capacitance in that circuit there. So I hope you found this video useful, first of all on how we can calculate reactance, and then how we can rearrange those formulas to calculate missing components that are going to give us the correct reactance in a given circuit.